Hello and welcome to this video in which we shall discuss function and inverse definitions using arrow diagrams. So here we're asked to determine if the mapping from the set of inputs to the set of outputs shown below represents a function, and if so, if that function is invertible. So when is a function invertible? When it's one-to-one, basically. So if you have multiple x's and maybe two y's, and then you have two x's going to the same y, for example, this is not one-to-one. Let's say we have an arrow here as well. So this is a function, but not one-to-one. What happens when we get the inverse of this function? So we're going to discuss that later in more detail, but the inverse basically means you're swapping the x's and the y's. So the inputs become the y's. So we have two x's here and three y's, because the y's become the x's and the x's become the y's. So it looks something like this. So in this case, this is not a function. So if it's not one-to-one, you cannot invert it. So it becomes automatically not invertible. So is this function here invertible or not? And is it a function to begin with or not? So let's check the inputs first. So here we have one arrow, 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 and one arrow. So this is a function. Now, is it one-to-one or not? Let's check the output. So one arrow going to the 8, one arrow here, one arrow, one arrow, 1, 1, 1, and 1. So each output only gets one mapping. So therefore, this is one-to-one. Therefore, it is invertible. So if it's one-to-one, then it's invertible. So therefore, this mapping does represent a function because there is one output for every input. The function is invertible because there is one input for every output. Let's try another one. So obviously, here, this is not a function to begin with because the 7 has two arrows coming out of it. If it's not a function, we don't care if it's invertible or not. So this does not represent a function because at least one input has more than one output. In this case, the input, so they want the actual example. So why are we selecting this as a not function, a non-function? Because the input 7 has two different outputs. So in this case, the input 7 has more than one output. And we submit. Let's try another one. So again, here it's very obvious that each input has one arrow and each output has one arrow as well. So this is just a one-to-one function. So it represents a function because there is one output for every input. And the function is invertible because there is one input for every output. So in this case here, for the inputs, we have one arrow coming out of each. So it is a function. It does represent a function because for every input, we have one output. So there is one output for every input. However, for the outputs, you can see that the 7 here has two different inputs. So this is not invertible because at least one output has more than one input. In this case, the output 7 has more than one input. And we submit. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.